How many of these molecules are polar? So we're going to determine the polarity of 5 different molecules, and to do this we are going to draw the Lewis structure, identify bond dipoles using differences in electronegativity, and identify net molecular dipoles based on molecular geometries. So we're going to start off with SO3, and to start the Lewis structure we need to determine how many valence electrons are in this molecule. So we know sulfur has 6 and oxygen also has 6, 3 oxygens, so we multiply by 3 and we get a total of 24 valence electrons. The basic structure of this Lewis structure is that sulfur will go in the middle since it's the least electronegative atom, while oxygen will go on the outside because it's the most electronegative atom. And then we can start by distributing electrons onto the outside atoms. We can already see that this Lewis structure is incorrect because, for one, there's no octet on S, and two, if we add up all these electrons, it actually equals 26 electrons when we need 24. So we're going to redraw this. And we can redraw this in actually 3 different ways. We can take a pair of non-bonding electrons from this oxygen and put them on a double bond with sulfur. We can take a non-bonding pair from this oxygen and put a double bond with sulfur. And we can take a pair of electrons from this oxygen and make a double bond with sulfur. So what this means is that this molecule has resonance. All 3 of these structures are exactly the same, and the molecule will actually look like this. It will have 1 1/3 bonds, and there are 3 shared bonds. And if we count up the electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we know those Lewis structures are correct. Next, we are going to determine partial positive and negative charges on this molecule. So we know that oxygen is the more electronegative atom. That means the oxygen has a higher attraction of electrons, so it's going to receive a partial negative charge, and each oxygen will actually have a partial negative charge. And so since these oxygens are negative, the sulfur will be positive. This allows us to draw our bond dipoles. So bond dipoles, the arrow points towards the more electronegative atom, whereas this line stays by the positive charged atom. So we know that this line is going to point to the oxygen, this line is going to point to the oxygen, and this line is going to point to the oxygen, giving us 3 bond dipoles. Next, we can look at the molecular geometry, and since this molecule has 3 domains, it is going to be trigonal planar molecular geometry. And if we draw this out, it's going to look like this, and these are the molecular dipoles. Again, they are pointing to oxygen, and since all 3 bonds are the same, or domains are the same, the bond dipoles will cancel and there will be no net dipole, making the molecule nonpolar. So this is a rule, and if these dipoles cancel, then the molecule is nonpolar, and we're going to remember that throughout this video. So next we're going to OF2, and there are 20 valence electrons in this molecule. So drawing the Lewis structure, let's just check real quick. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's the correct Lewis structure. Next, we can determine the partial negative and positive charges. We know fluorine's the more electronegative atom, so it will receive the partial negative charges, and oxygen will receive the partial positive charge. So now we can draw our bond dipoles. Again, the arrow will point to the more electronegative atom, so it's going to point to fluorine, and this arrow will also point to fluorine. Next, we can look at the molecular geometry of this molecule, and since there are 4 domains, but 2 domains are non-bonding electrons, it is a bent molecular geometry. And what this means is that this is what the molecular geometry will look like. The bent, it has 2 pairs of non-bonding electrons and then 2 pairs of bonding. And here are the molecular dipoles for this atom. Again, they're pointing to fluorine. And we're going to ignore that orange arrow for a second. And so since all 4 domains are not the same, we can clearly see this because this is not the same. the bond dipoles will not cancel. The bond dipoles will add. The net dipole will be in the downward direction, and since there is a net dipole, the molecule will be polar. So since the domains are different, these two dipoles will add and form this orange arrow, and that will be the net dipole, making the molecule polar. Moving on to BeCl2, there are 16 valence electrons in this molecule, and here is Lewis structure, and we can count up the electrons to show this is right. 2, 4, 6, 8, 10, 12, 14, 16, and there are 16 valence electrons, so that's right. And although Be doesn't have an octet, that is okay because it is an exception to the octet rule. So now we can look at partial negative and positive charges. We know that chlorine has the partial negative charge because it's more electronegative, and we know that Be is the least electronegative, so it will receive a partial positive charge. Again, we can draw the bond dipoles from this with the arrows pointing towards the more electronegative atoms, so these two arrows. Next, we'll look at the molecular geometry, and since there are two domains that are equal, this molecular geometry is linear. So if we draw that out, looks exactly the same as the bond dipoles. Arrows are pointing to chlorine. So, since the two domains are the same, the bond dipoles will cancel, and there will be no net dipole, making the molecule nonpolar. Now we will look at CCl4, and there are 32 valence electrons in this molecule. So, checking the Lewis structure, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So that's right. Now determine partial negative and positive charges. The partial negative charge goes on the chlorine because it's more electronegative, while the partial positive goes on the carbon. So drawing the bond dipoles, again, the arrows will point towards the negative charges. So this bond dipole will be pointing to chlorine, same for these other three. And since there are 4 domains that are equal, this is tetrahedral molecular geometry. And if we draw that out, it's just going to look like this. The bonds to chlorine. And since all 4 domains are exactly the same, the bond dipoles will cancel, and there will be no net dipole, making the molecule nonpolar. Now finishing with O3, there are 18 valence electrons, and there are 2 ways we can draw this Lewis structure. So this molecule does have resonance, and it has 1 and 1/2 bonds. So since this is the same atom, the 3 electronegativities are all exactly the same, and there are no partial charges at all. So let's go ahead and look at the molecular geometry, and we can see that there are 3 domains with 1 domain being non-bonding. So this is what it's going to look like. Here's the non-bonding, and here is the 2 bonding. And since the 3 domains are not the same, the dipoles will not cancel. Since they will not cancel, the molecule will be polar. And now we can finally go back to our original question of how many of these molecules are polar. And OF2 and O3 were the only ones, so the answer to this question is 2. Some common mistakes you can make in this problem are messing up on counting the valence electrons, messing up on your Lewis structure, messing up on the molecular geometry and not knowing what molecular geometry is, and messing up on drawing the bond dipoles by not knowing your partial and negative charges. Partial negative and positive charges.